The gentleman from California, the gentleman from Oklahoma is now recognized.
Thank you, Mr. Chairman, and thank you to the panel for being here today. We have kind of drifted from the specifics to the general and back and forth in this conversation. So first, let me turn to Dr. Bigot. Those are most impressive pictures compared to the last time several members of the committee were on site at ITER, the progress that's been made. You said in your written testimony, you used the phrase in referencing ITER's magnitude and complexity, quote, "No country, not even the most advanced, could have done this alone," unquote. Could you expand for a moment on the magnitude of the overall cost projected for the whole project and the number of disciplines and the number of engineering and scientific people required to get to this point?
Thank you very much for this question. Yes, clearly this tokamak, which is the largest we are ever conceived to build in the world, is associating many technologies. First, clearly, okay, the magnets, okay, and we have to develop these superconducting materials. Nearly, okay, 2,800 tons of this material has to be developed and with high standard. Vacuum, we need to make a vacuum in a chamber which is nearly 1,000 cubic meter. And we will deal with hydrogen, as you know, which fuse a lot. So we need to develop some specific pumps for that. And the US are performing quite well on this matter. Is another matter we need to have, okay, the US delivering on time. There is also all the heat exchanging. Okay, we are producing 500 megawatt, and on a square meter, we will be able to collect 20 megawatt per square meter. So all these technologies are so large that, and the size of the material is so important that we don't believe a single country could develop an industry in order to deliver on a reasonable time. We will deliver nearly the full construction in 25 years. And so we have the 7th largest country in the world together. And so you could imagine that even a single one could take maybe 4 or 5 times more. So it will not be expected. Just to give you an example, one sector of the large vacuum vessels, which is manufactured right now in Korea, it takes 4 years for the most advanced company in the world in order to be able to manufacture these sectors. Why? Because we need a very high precision. We need also full reliance because it's nuclear, okay, vessel. So no leaks at all. Every welding has to be precisely, okay, controlled. So my understanding is very clear. If we are not working all together, bringing the added value of our expertise and competence worldwide, it will be very challenging to do it.
Thank you, Doctor. Dr. Van Dam, various comments have been made about the different theoretics and the different perspectives, the different ways of coming about trying to address fusion. Could you touch for a moment on what varieties of fusion research programs are being pursued in other countries? We've listened to discussions about the United States. We know at ITER the consortium we're a part of, but what's the rest of the world up to?
Yes, the U.S., I think, is a world leader.
Absolutely.
About that. The Europeans have a very vigorous program in fusion energy and have had for some time, and we collaborate with them, for example, on the Joint European Torus, which is in the UK and it's being impacted by Brexit. We work on the W7X Stellarator, which is the world's largest in Germany. We work on the tokamak in Germany, another tokamak in Germany. We work with all of the countries in collaboration. Japan has a very vigorous program, and I myself have been going there for almost 40 years to do research. China has a very strong program right now. They're spending a lot of money in fusion energy. They're very serious about it. South Korea as well, India likewise. The Russian Federation used to historically have a very strong program, and we competed with them, and it is still strong. They have a lot of legacy work, but a lot of those scientists have migrated to the U.S.
One last question, Dr. Van Dam. Whether you are the optimist and you believe when the technology breakthrough comes, or you're a pessimist and you believe if the technology breakthrough comes, describe to us, where will the United States be if we don't participate, if we're not a part of these efforts, if we're not doing the research? Where will we be if or when, I would hope when, this happens? Describe for us just a moment what the world will be like for those who are not a part of this energy source.
The ITER project.
ITER or the concepts of fusion in general. If we get to the point where we have successful fusion power generation, but we've not participated, we're not a part of any of the endeavors, we've decided we don't want to spend any money, describe for a moment what it will be like to be left out of the next generation of energy.
Well, fusion and also fission provide base load energy, which is something that renewables don't quite provide. And they're also load following types of energy, which is very important for large industry and just our standard of living. If we are not in the ITER project, it may still go forward with the other 6 members. You know, we would have to decide what our program, we still have the same priorities in terms of burning plasma science, but how they would be implemented. And for the rest of the answer, I would like a crystal ball.
Bottom line is, of course, if success comes and we're not a part of it, then we'll become a second-class economic power because we will not be able to participate in the current technology at that moment of cost-effective energy for all purposes. Thank you, Doctor. Yield back, Mr. Chairman.
I thank the gentleman. Gentleman from New York, Mr. Tonko, is recognized for 5 minutes.